Now let's go ahead and see how to solve logarithmic equations. We're going to be using various techniques to solve them. Let's go ahead and see our objectives. We're going to solve logs. We're going to use logarithmic properties and then solve them. And we're going to use one-on-one property to solve them. So technically, we're using all the techniques. Let's go ahead and take a look at the first one. In the previous section, we've seen how to solve exponential functions. So we changed the exponential to log. In this section, we are solving logarithmic functions. So we will be changing them to exponential to solve. So let's go ahead and take a look at the first equation here. So here the log is single log and the log is by itself. That's equal to -5. The way I can solve this is by simply changing it to exponential. Remember how I change it to exponential? Draw an arrow from the base to the other side. So what happens is the 2 goes and kicks the 5 and I'm left with x. X is equal to 2 to the power -5. 2 to the power -5 is 1 over 2 to the power 5, which is 1 over 32. Now let's look at the next problem here. The log is by itself. Very good. So what I'm going to do is draw an arrow from the base to the other side. So the 5 goes and kicks the 2. And I'm left with x minus 8. X minus 8 is equal to 25. Adding 8 on both sides, I end up with x is equal to 33. Now let's take a look at the next one. Do I have a next one? Whoops. Yes, I do. The log is not by itself. It has this extra 6 here. And what do? I'm going to get rid of it by dividing by 6 on both sides. So I have ln(x) is equal to 30 over 6 is 5. Remember, ln(x) is nothing but log x to the base e. Because I don't have to write log x to the base e, I simply write it as ln, but you should know that is to the base e. Now once I see the base, what do? Draw an arrow from the base to the other side. And the e goes and kicks the 5. And what am I left with? X is equal to e to the power 5. Now let's go ahead and take a look at the other type of log equations. Now here you will see that I have 2 logs, and that's not what I want. I should always have a single log. But can I combine these two? Of course I can, because addition becomes multiplication. Double logs now become single log, and the addition becomes multiplication. And now, what do? I have a single log. Excuse me, sorry. I have a single log. I draw the arrow from the base to the other side. And now, excuse me, sorry again. And now what do I have? X minus 1 times x plus 1 is 4 goes and kicks 3. That becomes 4 to the power 3. And what is x minus 1 times x plus 1? This is simply x squared minus 1 is equal to 4 cubed is 64. I add 1 on both sides. I end up with x squared is equal to 65. And x is equal to square root of 65. You will have a positive square root of 65 and you'll have a negative square root of 65. But I'm only going to take positive because keep in mind, I cannot have a log of a negative number. When I plug negative 65 in here, this whole thing becomes negative and that does not work. Okay, so I only take the positive 65. Now let's go ahead and take a look at the next one. Again, I see 2 logs. and a subtraction sign. So you know what to do. It becomes division and single log. I don't see a base. Base is automatically a 10. And this is 2x minus 1. Numerator goes on the top. Denominator goes on the bottom. The whole thing is equal to 2. And now, once I have single log, what do? Change the log to exponential by drawing the arrow from the base to the other side. And when I do that, what do I have? I have 2x minus 1 over x is 10 squared. What is 10 squared? 10 squared is 100. So this is 2x minus 1 over x is equal to 1, 0, 0. And now, what do? What do I have here? This is a fraction. Again, there's so many ways to do it. All I'm going to do is divide 100 by 1, and I'm going to cross multiply. So I have 2x minus 1 is equal to 100x. So I'm going to subtract 2x from both sides. And what do I have? Negative 1 is equal to 88x. Divide both sides with 88. So what do I end up with? I end up with x is equal to negative 1 over 88. Keep in mind, I cannot have a negative log. I cannot find the value of a negative log. So when I plug this right here, that's not valid. So this whole equation, unfortunately, has no solution. So a good practice is once you have your answers, you should always go ahead, plug it in and see if you end up with a negative log. And in this case, I do end up with a negative log because when I plug in here, I get a negative and I cannot find the log of a negative number. So this one has no solution. Now let's go ahead and take a look at the next one. Hopefully this does have a solution. This is addition. So addition becomes multiplication. Double log becomes single log. So addition becomes multiplication is equal to 1. Now I have single log. What do? Change this into exponential function. And I have x plus 5 times x is equal to 6 to the power 1, which is 6. And now when I multiply, I have x squared plus 5x is equal to 6. I'm going to bring the 6 to the other side. I have x squared plus 5x minus 6 is equal to 0. Do you see a quadratic equation here? Let's go ahead and factor. What are factors of negative 6? That add up to positive 5. X plus 6 and x minus 1. And then I have x is equal to negative 6 and x is equal to positive 1. Now let's go back and see, can I have a negative log? So when I take this and plug it in here, I get a negative log. So I cannot have that. So my only solution is x is equal to 1. So your only solution is x is equal to 1. So a good practice is to always check, plug it back in and check. What is always the last step when solving your logarithmic equation? Plug and check your answer. All right, now let's go ahead and see what is one-to-one property. So it clearly says if I have log s to the base b, log t to the base b, if the bases are the same, and if I have the log, then simply s is equal to t. Now let's go ahead and take a look. I have log base 2, log base 2. So if just like exponential functions, when the bases are the same, the powers are equal. When the logs have the same base, then the numbers are equal. And now I have x minus 5 is equal to 4. X is equal to 9. Easy peasy, lemon squeezy. Now let's go ahead and take a look at the next one. Oh, wait a minute. I can't cancel because this is one log and these are two logs. But I can go ahead and combine these logs, can I? Of course I can. So I'm going to have log, this is too thick, log of x plus 3 is equal to, addition becomes multiplication, double log becomes single log. So x times 3 is 3x. Okay, now I have the same log, same base, because if I don't see the base is automatically a 10. And now I have x plus 3 is equal to 3x. So I subtract x from both sides, and I have 3 is equal to 2x. Divide by 2. Oop, that's not a 2. Divide by 2. And I have x is equal to 3 over 2. That's a one-to-one property. So I'm going to make them into single logs. And if I see logs on both sides, boom, boom, cancel it. And again, same thing here. Don't get confused between this and this property. In this problem, as you can see, I have logs only on one side. I don't have a log on this side. But if I go back to one-on-one, I have log on both sides. See, I have log on both sides. All right. Same thing here. I have logs on both sides, but here I have double logs. So what am I going to do? I'm going to combine them. How do I combine? Addition becomes multiplication. And here I have ln 14. So once I see that they have same ln's, boom, boom, cancel them out. But the condition is I should have single logs on both sides. If they're double logs, go ahead and change them to a single log. And once that's done, let me go ahead and expand this. This is x squared FOIL, remember? Minus 2x plus 3x minus 6 is equal to 14. So this is x squared plus x minus 6 is equal to 14. I subtract 14 from both sides. What do I end up with? X squared plus x minus 20 is equal to 0. So here I have x factors of negative 20 are positive 5 and negative 4 is equal to 0. That means my x is equal to negative 5 and my x is equal to positive 4. Remember, when you have two equations, you should always go back and plug in. So when I take my negative 5 and plug all the way in here, I get ln negative 5 plus 3. Can I have a log of a negative number? Nope. So my only solution is x is equal to 4. So here the key is, once you have your answers, you should always go back and check which number gives you a negative log. Remember, I cannot have a log of a negative number. I cannot. Whatever the number is, let's say n, I cannot have that. All right.